Hey guys, this is part 2 of your Unit 7 test review. So we're going to start with number 16. Sorry there's no 14 or 15. There was, but formatting got messed up. Anyways, so number 16, given, we can put in our given, angle 4 and angle 7 are supplementary. I'm just going to write our step. And angle 7 and angle 6 are supplementary. Alright, so now we have the measure of angle 4 plus the measure of angle 7 equals 180. Well, that's the definition of supplementary angles, because we're just changing the format. Definition of supplementary angles, because we are just changing the format of this to this. Right? They're the same thing. Angle 7 and angle 6 are supplementary. Once again, we're just changing the format. So this is definition of supplementary angles. Okay? Substitution property of equality. So because these are both equal to 180, they're both equal to each other. We just set them like that. So we have measure of angle 4 plus the measure of angle 7 equals 180. Or, sorry, not equals 180. My bad. Equals the measure of angle 7 plus the measure of angle 6. It was equal to 180, but that's not the answer for that. Alright, so now we can just get rid of the measure of angle 7, right? Because it's on both sides. So we just have measure of angle 4 equals the measure of angle 6. And that's just the subtraction property of equality. Alright, and lastly we have angle 4 is congruent to angle 6. Guess what? We're just changing the format for this. So this is the definition of congruent angles. Right? That's it. And that's how you do that proof. Alright, take a minute to write it down, pause the video if you need to go over something. Alright, I'm going to move on. Okay, number 7. This is not a hard question, but it looks like it. Or 17, not 7, sorry. Alright. Alright, we can't get it all. Okay, there we go. Using the figure below, find each measure. So if AB equals AE, this is the triangle we're looking at, name two congruent angles, it would be these, right? Because these are congruent to each other. So angle ABE, you have to go all the way to E because that's what the triangle is congruent to angle AEB. Alright, that's that one. Alright, the next one, we're starting with a clean slate. If angle ABF, that's this angle, is congruent to angle AFB, that's this angle, meaning two congruent segments. So this is our isosceles triangle that we're looking at. So the two segments that are congruent, AB is congruent to AF. Okay? So now we can erase that. If CA is congruent to DA, you get it. That's our triangle. Name two congruent angles. It's an isosceles triangle, so those two, right? So angle ACD is congruent to angle ADC. Alright? So now we start over with it. If angle DAE is congruent to angle DEA, so that gives us this triangle. Name two congruent segments, AD and ED, right? AD is congruent to ED. All right? If angle BCF is congruent to angle BFC, that gives us this isosceles triangle. Name two congruent segments, well that's these. So BC is congruent to BF. And lastly, if EA is congruent to AH, name two congruent angles. Well, this is our triangle. Those are congruent. These are our two congruent angles. So angle AHE is congruent to angle AEH. Okay? So let's you do that one. Number 18, find x in the figure below. All right, this is an isosceles triangle. So these are equal to each other. So you just set them as equal to each other. 2x minus 1 equals x plus 7, right? So we get x equals 8. So we can find each side. This one is 15, also 15, right? We're just plugging in for x, and this one is 4. Okay? Simplify the ratios. There are 12 inches in a foot. So this is 12 feet over 36 feet, right? So, which is 1/3, right? So that's the ratio, 1/3. This 5,280 feet is equal to 1 mile. So this is 6 miles over 2 miles. By the way, you could have converted this one to inches, like you would just multiply this by 12, but it's so much easier to divide this by 12. And you could have multiplied this by 5,200 and whatever, 290. It's 5,290, sorry. All right, but that's way more complicated, so we just did this. So we end up with 3/1 is our ratio, all right? I would have left that one in there if I were you. All right, millimeters just means 1,000. So this is, I'm just going to say 750 millimeters over 5,000, right? You either divide this by 1,000 or multiply this by 1,000 millimeters, which gives us 75 over 500, which gives us 15 over 10, oops, over 100, which gives us 3/20. And that is our ratio. Okay? Okay. Number 20. The perimeter of a rectangle is 250 units. So rectangle P, which is our perimeter, equals 250 units. The width to length is 2 to 3. So let's use our dummy variable. I'll use m. I like to use m. So 2m and 3m. Okay? So this is also 2m because it's a rectangle. And this is also 3m because it's a rectangle. All right? So you add them up to get the perimeter. So you just get 3m plus 2m plus 3m plus 2m again equals 250. You end up with 10m equals 250. So m equals 25. And that makes this 50 units and this 75 units. Okay? Let's look at the next one. The area of a triangle, so we have a triangle, is 40 units. So A equals 40. The ratio of the height. Now this is important. The height of a triangle is this line right here. So the ratio of the height to the base of the triangle is 10 to 2. So this is 10. I'm going to use t as my dummy variable. And 2t. I know it doesn't look like this should be that much smaller, but it is. All right, what are the height and base of the triangle? So in order to get the area of a triangle, it's 1/2 base times height. So we have 1/2 times 2 times 10, times 2t times 10t equals 40. All right? So we have 10t squared equals 40. So t squared equals 4, and t equals 2. It has to be plus 2, not minus 2, because we're talking about a measurement. So the base is 4, and the height is 20. All right? Okay. 22, solve the following proportions. So we cross multiply, right? We get 9x equals 45, x equals 5. Right, we're cross multiplying. Here we cross multiply again. 3y plus 6 equals 4y. Subtract 3y from both sides, 6 equals y. Okay. Over on this side, not this marker. Let's try this one. Okay. On this side we're cross multiplying, so let's see. We have z squared plus z plus z, right? Z squared plus z minus 2 equals -2. Okay? We can move this over. We get z squared plus z equals 0, right? Because we got 2 to both sides. Z plus 1 equals 0, so z equals 0 and -1. Okay? So that's how you do those ratios. Okay. Number 23 says solve for x, y, and z. Oh, no, this is that one. Alright, all these markers are no good. Let's try pink. Okay. So, U and Q are similar, right? We can tell this by the shape. N and S are similar. M and R, sorry, that's supposed to be a diamond. M and R are similar, and P and T are similar, okay? So so first let's find the ratio, okay? MN, right, is similar to RS. So the ratio is 30 over 18 or 18 over 30, depending on which way you're going. So this is 15 over 9, 5 over 3. That's our ratio, okay? So we want to find x. NP corresponds with ST. So in order to get smaller, right, we have to go less than 1. So we're going to multiply 25. So x equals 25 times 3 over 5, right? Because we're going smaller. It has to be less than 1. So x equals 15. Okay? So now for y is similar, or TU is similar to PQ. So we, once again, are multiplying. So this time we're multiplying to make it bigger, right? Because this is the smaller one going to the bigger one. So we have 15 times 5 over 3 equals 25. And that's y. Okay? Y equals 25. So finally, we need to find z. Well, guess what? Angle M, similar, or is congruent to angle R, right? If they're similar triangles, their angles are congruent. So z is just 115. Alright? I hope everyone gets that, because we are moving on. Okay, number 24. The triangles below are similar. Solve for x. Alright? So, let's split this up into y and z. Alright? We need to find those, because the fact that this is 10 helps us, but not that much, right? So let's start with 8, okay? Let's find out what y is. So, 8, the line DG, which is 8, shares a vertex point with two parts of the hypotenuse, y and 10 minus, y and 10, sorry, right? So, we have 8 over y equals 10 over 8. So we end up with 10y equals 64. So y equals 64 over 10, which equals 32 over 5. Okay? Okay. So, 10 over 5 is 50 over 5, right? So 50 over 5 minus 32 over 5 equals 18 over 5. So that's what z is, 18 over 5. All right, and now we can just solve for x. So x over, right, because it shares a vertex with z and y, which we know what they are. So x over 32 over 5 equals 18 over 5 over x. Now, a great way to do this, remember, when you're dividing fractions, you have, this is not part of this problem, but a over b, or a divided by b over c. We keep, switch, flip. So a divided by b over c. Keep, switch, flip. So we end up with a times c over b. Okay, so we get x times 5 over 32, right, equals 18 over 5x. Those cancel. This cancels and makes us 2, so we get x squared equals 2. So x equals the square root of 2. Right? Oh, no, I'm so sorry. 16 and 32 cancel. That one's my bad, guys. So 18, 32. Both are divisible by 2. This is 16. This is 9. Sorry, guys. I was like, this doesn't seem right. So we end up with x squared equals 160 minus 16, 140, 160 minus 16, 144. So x equals 12. Alright, so that's how we do that one. B are similar. So let's draw these. A, B, C, triangle, X, Y, and Z. They're similar. They're not supposed to be the same size, but you know. Alright, so the length of triangle ABC are, and you can just write them anywhere, 10, 12, and 15. The shortest side of triangle XYZ is 30. So you look at ABC, the shortest side is AB, because that's 10. So the shortest side of XYZ is 30, and it's the corresponding side to AB, or to 10, so this is 30. Alright? So now, we need to find out what the other two sides is, and then what the perimeter is. Alright? Which is just all three sides added up. So, what we do, so clearly, so 10 over 3, let's do 30 over 10. I don't know if that's over now. Oh, 30 over 10, right, equals 3 over 1. So if we're going from here to here, we're multiplying it by 3. So 12 times 3 is 36, and 15 times 30 is 45. So that's the other two sides. Now to get the perimeter, which I'm just going to write as P, you just add these all up. So that's 66 plus 45, 71, 111. And that's it. How do you do number 25, guys? Okay, number 26. In triangle PQR, ST and RQ are parallel. If PS is 6, SR is 4, PT is 9, find TQ without using similar, I'm just going to call this X, without using similar triangle proportions. So that just means you can't assume that these are similar, like by doing this triangle and then this triangle. So instead what you're going to do, what we talked about the other day, 6 over 4 equals 9 over X. That's it. And then you cross multiply, you get 6X equals 36, so X equals 6. That's it. Let's look at number 27, which we're going to do the exact same way. In the figure below, AB is 8, EF is 6, and FG is 3. Find BC, which I'm going to call Y. Same thing. You just do this over this equals this over this. So we just do 8 over Y equals 6 over 3, which simplifies to 2 over 1. Keep in mind, when you have 3 parallel lines intersected by 2 transversals, you're able to do this, okay? And when you think about it, these are 2 parallel lines with 2 transversals. You see that? These are our transversals. Which is why we're able to do this. So we just calculated 8 equals 2y, y equals 4. Alright? So BC is 4. Okay guys, we're on the last problem, so bear with me a little bit longer. 28. Use the picture below to solve the following similar right triangles. So for A, if CD equals X, right, AD equals 4, and AB equals 7, that's this whole thing right here, find CD, so find X. So since this is 4 and this is 7, DB is 3. And when you look at X, it shares a vertex with, this is the big hypotenuse, right, with AD and DB. So you do X over 4 equals 3 over x, right? Because the geometric mean, which is one of these three, is calculated this way. So you end up with x squared equals 12. So x equals the square root of 12. Remember, it's positive square root because it's the length. So x equals, and when you simplify square root of 12, you get x equals 2 root 3. All right? Now let's look at B. Wipe this off, clean slate. AC equals y. So this equals y. AD equals 2, and DB equals 3. All right? Find AC. Well, first of all, AB is 5. And y shares a vertex with AD and AB, because those are two parts of our big hypotenuse, right? So we have y over 2 equals 5, right, over y. So we get y squared equals 10. So y equals the square root of 10, right? And number C, we have CB equals 4, DB equals 5, and AD equals Z. So we need to find Z, or AD. All right, the way that we would do this, we would use this leg, because that's marked, and note that it shares a vertex with DB and AB. But we don't know the exact numerical value of AB. However, we do know that AB is Z plus 5, right? So we do 4 over Z plus 5 equals 5 over 4. We multiply that out. 16 equals 5Z plus 5. 5Z plus 25, which we end up negative 9 equals 5Z. So this is incorrect. It should not be a negative number. Sorry about that, guys. Oh well, happens. But Z ends up being negative 9 over 5. Okay? Or for sure. Z equals negative 9 over 5. Right? Z. The last one. Yeah, I think that's the best I'm going to get it. That's fine. Alright, so for for number D, AC, which is this line here, I know you can't really see the C, is W. CD, this, is F. AB is 11. And AD is 9. Alright? So find AC and CD. So first of all, if this is 9 and this is 11, this is going to be 2. So we look at AC, and it shows a vertex with AB and AD. So we do, I'm just going to write it right here, W over 9 equals 11 over W. W squared equals 99, right? So W equals root 99, which is equal to, when you simplify, 3 root 11, okay? That's W. And we still need S. Well, F shares a vertex with 9 and 2, or AD and DB. So you do F over 9 equals 2 over S. So you end up with 18 equals S squared. S equals the square root of 18, which is 3 times 3 times 2, so which equals 3 root 2. Okay? And that's D. So this concludes Unit 7 Text Review Part 2. So good luck, guys. I hope you do well.